So, first of all, welcome at Stream. My name is Jeroen, probably already said that name before. I work at Stream as iOS Developer Relations Lead. So there are a number of people here in the crowd that I get to deal with directly as content creators, and my role with Stream is to get the word out on what products we create and just get engagement with iOS developers. So a technical role, but very much interesting to just see what the iOS community and also the developer community as a whole is doing, and to make sure that we create a product and also have a message to the community out there that is on brand but also on topic, so that people actually want to interact with us and hopefully also convert into customers of our products. So I told a little bit about myself already. I also have a podcast, AppForce1, check it out. Also wrote a book about being a lead software developer. That's something I did at my previous role at a big insurance company in the Netherlands. Been doing software development for over 20 years now, so I've seen a lot of stuff, and I've been doing iOS for 10 years now. It's a lot of fun. It's a field that keeps changing, and yeah, you never know what you'll be working on next year, and that's, I think, part of the challenges, but also part of the fun of working in software development. So why do I want to talk about PassKeys and WebAuthN? It's a bit of an interesting topic to me, because I think if you look at these two technologies, I think they're sort of like the sleeper features that have been announced during WWDC. And the fun bit is actually that PassKeys, Apple pitched it as something totally new in the talk and the page that they put online this year. But actually, if you look at the back catalog of WWDC videos of 2021, pretty much the exact same talk has already been given last year, and also the code sample is pretty much the same as it was last year. So why do I want to? Oh, sorry. So why do I want to talk about it? It is something that is, I think, hopefully, something that's going to come to fruition in the next 12 months, maybe 24 months. That it is something that is normal, that you just log in with your device instead of having a username and a password. There's still some caveats attached to that. So what happens if you lose your device? What happens if you want to move from Android to iOS, or vice versa? How do you bring your credentials with you? Because that's still, to me at least, an unanswered question, and I hope that there will be a resolution to that soon, because I think that's one of the last bits that is stopping total adoption of these features. And I hope after my talk that you have an idea of why it's a good thing to adopt, and also what the benefits will be of adopting PassKey and WebAuthN. So that's the intro of my talk. Stream, what is one of the things that we do? There are more things that we do, but one of the biggest products that we have right now is Stream Chat. It's the #1 chat API for custom messaging, and it allows you to add fast real-time messaging to your app in days. So, and that's really true. Instead of spending months developing it in-house yourself, you can just take our SDK and then get it done within a week's time. You have like a full-featured chat feature in your app, and there's a lot of companies actually using it. If you want to try it out, there's a free trial, no credit card required, so you can have a look at what we have available. It's trusted by many companies. If you've been doing online conferences in the past 2 years, there's a good chance that you actually have interacted with a party like Hopin. They create an online conferencing platform, and one of the cool things I think to know is that the chat feature within their product is completely built on the Stream product, and there are a number of other logos that we're very keen on showing to people, because yeah, it's just some big names in there that do a lot of chat with our product. So what you want to know about WebAuthN and PassKeys? PassKeys, at least according to Apple's pitch, it's based on industry standards for account authentication. That's pretty much the WebAuthN bit. And WebAuthN is a standard that is developed by the W3C and the FIDO organization. And it's a web standard that has been around for quite a number of years already. And pretty much all browsers support WebAuthN, except Internet Explorer. But that's been axed this week, so nothing holding us back there, right? And but what it is, it's a way, it's the baseline WebAuthN for PassKeys, and PassKeys allows you to log in, authenticate yourself without using a password. So why would you want to do that? Right now, if you use username password, the thing is you can of course remember those. But if you want to remember your password, what you do, you tend to have like a very limited set of passwords, or you have to use some sort of third-party tool to actually allow you to remember all these passwords. So stuff like 1Password and similar products. It also is very easy to share a username and password, but then once you shared it, how can you regain control of this account again? Well, you have to change the password. But the thing with PassKeys is that if you have a username password and you use it on a platform, you actually send your credential in a hashed form, hopefully, to the other side of the internet, so to the server actually. And with PassKeys, the big benefit there is that you only do a signature with a private key, and that can be checked on the server with a public key. So your actual credential is never sent over the internet, and the signature that you send over the internet is actually time bound. So it's not something that you can capture and then reuse and reuse and reuse. And actually, what you can capture, it would ever only work on one service. Because if you have registered yourself with a passkey on another service, it's a different public key that they're using there. So even if you would sign the content correctly, you're still missing some bits and details that would allow you to actually do a signature that is valid for that other service, because the actual credential is just never shared with them, and also the way they check it, it's a little bit different for each service that you're using. So the goal with Apple is, with adopting PassKeys, is to give people a simple, secure way to sign into your apps and websites across platforms with no passwords required. Okay, let me catch my breath here. This is like marketing blurb by Apple, and basically the keywords here is simple and secure. So in practice, how would this look? You basically come up to a website with your phone or your laptop or whatever, and you just say, okay, I want to log in, and then you have to show to your device that you're actually there. So you have to present your fingerprint or your Face ID or whatever. You have to tap some key device, and you're logged in. There's no entry or no pasting of usernames and passwords required anymore. So it all sounds great, but what is it actually? So it's something that is based on something that, as I already mentioned, the FIDO Alliance and the W3C has published, and it's called WebAuthN. And what PassKeys is, it's actually an implementation of actually an adoption of WebAuthN with applesauce on top of it. Because what does Apple add? It's like a bit of streamlining. So what they actually do is that you actually can synchronize your credentials through iCloud Keychain. Apple says it's secure, so hey, we all trust Apple, right? And but the thing is, they also make it possible with some additional API on top that you can do this QR code-based login that they also demoed during the WWDC. So that's something that's different between 2021 and 2022 talk. They showcased how you can do the WebAuthN login, but now this year they also showed, hey, I have my laptop, I log in, I take my phone, I point at the QR code, I do something on my phone, and then on the local side, so between these two devices, a handshake is performed over Bluetooth or near-field communication. Not entirely sure yet what it is, but at least there's a local loop exchange happening, which can then be presented by the device that showed the QR code back to the service that you're trying to log into. So, and that at that point, you securely logged in without this device ever knowing your credential. And yeah, that's the applesauce, the Apple magic that they're trying to add on top of it. So what Apple adds to WebAuthN is PassKeys, syncing through iCloud Keychain. But with iOS 16, that's the shareable through Apple handoff. So you can actually, I haven't seen the interface yet, but apparently you can pick one of these passkeys, and then on a near device you can say, okay, you can get this passkey off of me, and then somebody can import it in their keychain and they can start working with it. And as I already mentioned, the QR code-based local handshake for off-device authentication. So that's basically you authenticate with your device in your hand, but the authentication is actually used on a secondary device that is not aware. Could be like a Windows laptop or whatever. You can just log in and authenticate yourself there without having to share your secrets on that other device. So WebAuthN requires 4 parties, and this is a bit of the technical bits of the specification. They're listed here, so that's the relying party, the authenticator, the web browser or app, and the user. So, and as you notice, The relying party, that's pretty much the service that you want to log into. So there's something on the internet that you want to prove to that you are who you are claiming to be. The authenticator is a passkey in the keychain or some other secure device. So that's like a YubiKey or one of these Google Titan devices, like a little USB key-like thing that actually contains some logic that allows you to do this, to store a private key. And then there's the web browser or app, so that's the bit of software that's on your side, on your device, that actually has to read this authenticator to be able to do the process, the handshaking, and the calculation of a hash so that that can be sent back to the server, a signature I should say. And the user is actually the person owning the authenticator and running the web browser or app. And what's quite often the case is that you have to do an affirmative action to show that there's actually somebody alive next to the authenticator. So with a YubiKey, you typically have to touch a metal contact area to make sure that the key triggers. And with an Apple device, you have to do like a Face ID, Touch ID, something like that, that actually proves to the device that, hey, you are actually present and willing to share this credential, or to use this credential, I should say. So these four parties are involved, and you can already tell that there's some moving bits involved there. So with all of these things, there are two phases that need to happen. It's the enrollment, so you basically have to tell somebody you have this device on hand and that you want to use it. That's basically a registration. And you have to do like a login, the assertion. So what that means is that you actually use the device to show to the other service where you are enrolled on that you are again back, and that you want to prove that you are there, and that you actually want to log in and use their service as the person that you claim to be. What's interesting there is that there's a possibility with these authenticator device that you can actually attestate. It's like one of these trip your tongue words, but it allows you to do attestation of the actual hardware token that you're using. And what that means is that in some fields it is a requirement that if they send out secure elements like a YubiKey or some other token, that you can actually verify on the server end that the device that is being used for the enrollment is actually a device that you are familiar with, that you trust, so that it is a device that is untampered, that it is something that you want to use and not some sort of a software emulation of one of these tokens. And there's just some cryptographic signatures and verification of those involved. It's chain verification, as you quite often see in server-side TLS certificates. So as I already mentioned, the enrollment is pretty much the registration. You tell a service, I got a key and I want to use it, so here's my public key. And then the assertion is that you actually get a challenge back from the server, and that you use your private key to create a signature on that, and which you send to the server, and then the server can actually verify that the signature that you send back is valid, and then they know, okay, you at least have access to the private key that we expect, so we assume that you are who you are claiming to be. So there's some specifics here. I hope it's readable. It's a bit small. WebAuthN authenticator flavors. So you already heard me talking about it can be your phone, it can be a YubiKey or a Google Titan key and some other things. And basically the standard claims that there are 3 different types of authenticators that you can deal with. And the first of all is the roaming authenticator. That's your typical USB key type device, so a YubiKey. And it's usually something that attaches over USB, Bluetooth, or some other wireless technology, and it allows a web browser to communicate with the thing and do the authentication. And then there's virtual authentication. Those are purely based in software. And at least the standard, they claim, if you have a virtual authenticator, they have a tendency to be not very secure. Because you store the private keys in some sort of a database, and where does this database reside? We don't know. It can be a text file somewhere on the file system, right? So they claim there are some security drawbacks, and it's great for testing to have a virtual authenticator. And then there's platform authenticators, and that's probably where you think, okay, that's where Apple comes in with the secure enclave, right? That's something that is built into a device. So I don't know about you, but I have a tendency to a USB style device, that's something that I could quite easily see myself lose somewhere. I just drop it somewhere or whatever. But doing the same thing with a phone or a laptop is quite a bit harder, I guess. But a platform authenticator is built into a device. So you would say, okay, that's Apple's secure enclave. So it's convenient, it's bound to a particular device. So yeah, you can't take it out of your laptop, you can't take it out of your phone. It is in there, embedded. It's part of the hardware. And what's interesting there is that Apple, with their PassKey solution, by syncing the authenticator over iCloud Keychain, is that they actually turn this thing that you would expect to be in a secure enclave into somewhat of a virtual authenticator with not as much of the drawbacks as the standard claims these virtual authenticators have. But it is something to be aware of, that if you use WebAuthN on an Apple device and you have iCloud syncing enabled, it does sync through Apple's cloud, and you have to work under the assumption that that is done securely. It's a good chance that you actually do that, but of course people make mistakes. There can always be like some sort of 0 day in there that we are not aware of, and that you might run into, and that Apple then needs to fix accordingly. So my current knowledge on the topic, because I only got started with this on, I think it was Thursday or Friday last week. I do not have the QR code bits working just yet, because as Apple always is with their WWDC talks, they are they're very open with sharing code samples that are like device bound. So that's like a bit of iOS code, a bit of macOS code. But they mention anything that you need to do on the server. Yeah, you can do all these amazing APIs on iOS or macOS. Oh yeah, you need to do something on the server, but that's your problem, right? And then you're standing there, okay, there's sample code, and then the sample code says, okay, make sure that in this file you change the example.com URL into your domain name. And oh, by the way, figure out how to do this implementation yourself. Fortunately, Tim Condon, who's recently also done some other work for Stream, on his own figured out a little bit of this WebAuthN stuff, and he told me that he's working on getting a WebAuthN framework type implementation available at some point for Vapor Swift, and that's something that I'm very keen on getting. So I'm trying to help him out in any way I can, but Tim Condon is such a guru on Vapor. I can only help him by cheering and applauding his work, basically, because he's much quicker with Vapor Swift than I am. But he also claimed that the code that he has available right now, it's unvetted. He hasn't reviewed it yet. There's no formal review done on it. It's only a partial implementation of the specification. So make sure that you only consider the sample code that he has made available to be something that you can just play around with a little bit. But for sure, don't put it in your next big project or your current project, because you're gonna run into issues there. There are other parties available that have amazing online login examples, not only like showcase how this stuff works, but also all kinds of languages that you can have, like a framework or a library available that allows you to easily integrate WebAuthN in your service. So I'm talking about Golang, PHP, Python, any of these typical server languages that you can come up with. Most of them have some sort of a standard implementation available for WebAuthN that is reviewed, vetted, supported, and upgraded when issues are there. I want to do a quick demo now, so I'm like very convenient here at my laptop, so I hope it all works out. What I have here for you is, first of all, I go to Safari. I try and make it a little bit bigger. Let's see how this looks here. Yeah, it's good enough, right? What's interesting here, let's make sure that I have a unique name. I just put in a name here. I click register. And then I get like this challenge here. Yeah, it's not hidden on screen. And there's something cool there. You can just say, signing in, you're done. And I say login. And in actually real world use cases, this is how actual user experience should be with WebAuthN. You can just have your device, and your device is your authentication. First thing I think, okay, but what if I don't have access to my device, right? Well, the thing is, because this is stored in as a passkey in my iCloud keychain, within reasonable time, it's also available on my phone, and I can just do the same thing on my phone again. But what's also interesting is if I do the try again option, and I get my magic stuff out of my bag. There should be a rubber band down here somewhere. Ah, there it is. It immediately proves you can easily lose these things because they're so tiny. What's interesting here is that you see a number of options here. So that's the attestation type. What this means here, if you do direct, it would basically request you on the server to do an attestation. So I'm not going to do that because I'm not sure if they are aware of my device here. But what's very interesting here is if I say I want to use a cross-platform thing to register. So I say, on this one I can just register stream again. I get a different pop-up, and it says something with insert and activate your secure key. So I just put in this thing, then I wait for it to light up, I touch it, and I'm logged in. Sorry, I'm registered, and if I then log in, I can just touch it, and I'm logged in. If I would do the same thing on my phone, I hope I can get to the website quick enough, yeah. So I just put in stream here on my device. I pick my authenticator out of here, and I have not registered on this device before, but I just say login. I say login, thank you, and then shouldn't tap twice. Okay, so and then it asks me, do you want to allow this website to log in with your security key? And I have my security key, and it says just put the device near your screen. Cancelled by the user. So I waited too long. I just hold it near it, and I'm logged in. The only thing I did not touch my screen. I just put an NFC enabled device near my phone, and magic happens, right? It feels a bit magical initially, but then once you start looking into the specifics of this, it's actually quite interesting what's happening under the hood, and that's cool to look at this one. I hope this is legible. Yes. I pick another user. This is cool. And it basically, you should look at this once you're back home. It basically shows you, okay, you want to continue, yes. And it basically shows you all the things that are happening. The key they show on the left is actually my device. And it says, okay, this is the raw information of your credential. Yeah, if you look at it, it's like, yeah, that's fine, all right. I can't even read that. But probably this is ECDSA, so that's some elliptic curve algorithm going on there. So elliptic curve is secure, at least that's what I'm told. And then you can authenticate with your credential, and the credential is now in PassKey in my keychain. I just say login, the browser goes to the server, that goes back, that goes to my authenticator. I have to say, yeah, I want to allow this, because this is the first time I'm doing this on this site since a reset. Touch my Touch ID, stuff goes back to the browser sends it back to the server, and then we're done, we're logged in. And this is one of the better examples to really get an understanding what's happening under the hood. And it's also very fun to put a proxy in between the browser and this specific service, because then you can also see what's going over the line. And it's basically a simple API, which I will go into in a little bit, because yeah, we want to see some code at some point, right? So that was like a quick demo of what this stuff actually does. As I already mentioned, Tim Condon did a nice quick hack job of an implementation of WebAuthN. He really put it together in like a few hours over the past 5 days. And it's a somewhat working Swift-based implementation. And once it's like really available, I plan on putting it in the Streams Vapor integration project, because we have a nice sample project available that does all kinds of social logins. So if you want to learn with Vapor Swift what you need to do to log in with, for instance, Twitter, GitHub, and I think it was Facebook or another social, but you get the idea. You can look at the code, see how it works and what it does, and it's actually Tim Condon who helped us build that project, and he also wrote a blog about it on the Stream website. So yeah, some Swift code. So as I mentioned, there's already something available. And now the scary stuff starts, because I have to open the terminal, right? I want to make this bigger, because I don't know about you, but if I'm in the back of the room, I could read this. Is this okay in the back of the room? Cool. So this is, this is just a Git repository. Oh, this is the slides, actually. I need to go to this one. As you can tell, I'm very well prepared. So this is the correct one. So this is just a Git repository that is available on Tim's context, and I just did a sort of a quick few small changes to make sure that it is working today. So I can just run this. This is a Vapor code base. So now I need to fill some time while this is actually running and probably fetching all kind of stuff from the internet. This is live demos for you, right? For some reason, it's all of a sudden slow. And you notice that it now says there's a server running on pretty much localhost, right? One of the peculiar things with this sample is that for some reason you don't use the localhost IP number, but you have to use the localhost name, otherwise it just doesn't work. And I'm using, oh, I didn't register yet, right? Then I register, then it says like add a new Android phone. I don't know why it asks for Android, but this is a Brave browser, Chrome based. Must be something with Google. I can use a secure key, or I can use this device. Then it says login. I can actually use my Apple Watch to confirm that dialog. So I logged in, and I now say stream, and I say sign in. I'm not touching my phone, I'm just pressing the button twice, I'm logged in. So this is how easy logging in should be, provided that it's secure. And this Vapor sample is not secure yet, but what's interesting there is that you can, oh boy, this is like way too small, right? Was it under themes? Yes, presentation. Oh, I actually have it on presentation. Must be my eyesight when I'm getting older, right? It won't be too long, and I need a cane to actually find my way, right? So yeah, I must admit, I'm in my 40s now, and yes, my eyesight has been deteriorating the last 5 years quite significantly. So, but what's interesting there is, especially if you look, I can't go in very much detail here, but I understand about like half of this code. So I would recommend you to read some specs first and then have a look at this, because I'm just still coming to grips with this as well. But what you see here is this is like the routes that you need on the Vapor implementation to make sure that you can actually have the API available that you need to have available to make WebAuthN work. And you can tell that it's like just, well, it's like 5 or 6 endpoints that you need to implement the API side of this WebAuthN thing. And then, of course, there's all kinds of things in the background that you need to do to create signatures, to verify them, to send them, to unpack them and pack them up again in the right formats, to make sure that you can actually send it somewhere and that it actually is working. But what is really nice about this is that this is quite a small sample code base that is still in development, but it does show you what it is that you need to do to get started with WebAuthN. I would recommend, if you want to get started with WebAuthN on your implementation, on your service, is that you don't use VaporSwift just yet, because this is just not mature enough yet. But if you take the Go implementation from Duo Labs, then I think you're good, because that's a proven implementation that's been around for a couple of years already. And then I go back to my presentation. So at least made true on my promise to show you some Swift code, right? As I mentioned, it's still a work in progress, but I must say that with the amount of code that's in this Vapor project, just this small amount of code, and then the level of integration that you can achieve with your Apple device, it's actually, well, it's kind of surprising. And the thing I'm really thinking about nowadays is, are WebAuthN and PassKeys going to be a thing or not? So I think it's still a little bit early to tell, but I think all the signs are good. because not only Apple supports it, Google is also backing it, Microsoft is behind it, all browsers support it, except Internet Explorer, but that's not a problem anymore since this week. And it's all based on industry standards, so it's W3C based, it's all open specifications that have been vetted. And yeah, it's just something that it seems like the tech world is really ready to spring this magical experience on end users, and then we as developers have to like come to grips with what it actually takes to implement this. But I think it's not as bad. If you can do your regular OAuth implementation, you can do a WebAuthN implementation just as easy. And WebAuthN works really nice in an OAuth context as well. So as I mentioned, there are many integrations available that are production ready. Duo Security and Yubico have been a big driver of FIDO anti-WebAuthN adoption. So of course, if you sell the devices, you want to enable people to actually use it. And I think for these companies, the enablement of the usage of these devices is very much in their interest. So there's still some questions that I have, because how do you transition your logins between iOS and Android, for example? Imagine, I wouldn't recommend it, but you're an iOS user and at some point you're ready to just ditch your iPhone and go to Android. You probably want to bring all your logins with you. As I already mentioned, with usernames, passwords, that's easy, but how does this work for these passkeys? You can share them between Apple devices, but how do I get them to an Android device? And vice versa, of course. You don't want to have a login on your credentials, right? Because you want to own your own credentials and your web logins, and you don't want to be dependent on that, strictly dependent on like a platform provider like Apple or Android. FIDO is working on something, some sort of a specification that says something about how this could be enabled, the sharing of your credentials or the exportation and importation of your credentials from a device or from a context. But if you want to be on the safe side, you can just put your credentials on one of these things and they work on pretty much any hardware out there. But then, of course, you have a little bit less convenience compared to what the passkey implementation of Apple actually brings. So I'm poking the cat here, and that means that is there anybody with a question?
I had one question, but now I have two.
What's the second question?
The second question is, the whole thing is based on public key encryption. So Apple stores the private key in your keychain,
yeah,
and then the public key is sent to the web. But you can export your private key from the keychain. So can't you not export that with the pair and then import it in your Android thingy?
Well, you're an iOS developer or a Mac developer. You can do that. But would you expect your grandmother to be able to do that?
Yes, of course.
Well, then she's a software developer as well, right? But
yes,
there is some, of course, technically it is.
If you're a Fortran coach, she can do it.
Technically, it's already possible. Yeah. They're not in your keychain per se, because you need something with. There's some matching happening with iCloud keychain syncing that does involve the secure enclave, and you need to do some things on a new device to make sure that your new device is actually enabled for iCloud keychain. So there is some. You can find an article on that on the Apple website that they do some sort of vetting and testing on the background that you are. Yeah, you have to go to quite a substantial process to actually get your iCloud keychain syncing working on a new device. So yeah, it is technically probably possible, because the private key is not in the secure enclave, because if it would be in the secure enclave, there's no way to get it out. Yeah. But yeah, it is a process that has to be like optimized so that any person owning an iPhone or owning a Mac can actually do it, because you just want to have a wizard with all kinds of warnings around it, and some security still in place that you carry over to your other device. So then you would be in a situation, if you get the password at that point, all your credentials are probably gone. But
yeah, that's something for WebAuthN 2. Probably.
Yeah, they're actually on the second version of the standard already.
So my first question was,
yeah,
I see you when you registered and you log in, you first register and then you log in. But it's of course a very bad user experience. Or is it part of the system that you have to register first and then log in again? Or can you just say,
no, it is in the sample code.
Oh, it's all the sample code.
If you do the enrollment, that's pretty much you sharing a public key based on your private key with the service provider. And At that point, of course, you could choose and implement it in such a way that once you did the enrollment, you're already logged in because you already sort of proven that you are who you are, or at least it is at that point that the server assumes that you are who you are because they accept your private key and then go, okay, unless you do the attestation, because then you can do all kinds of extra checks on the server end with some information that you got that is a description of the device that the user is actually using to store their private key in. So you could very well implement it in such a way that a company sends out these secure elements and that you can only register using one of the company's secure elements.
Cool. Does the relying party, that is the website, does it get any information about the type of authenticator being used? In other words, can it do remote attestation, or can it block out users that don't use a blessed system?
Yeah, if you do direct attestation, then and also if you do indirect attestation, some metadata about your secure element is sent with the request to the service, and this it actually leads to an additional piece of information in the warning pop-up that most browsers provide. They actually have a line in there: do you want to share information on your security token with the other side? And then there's some explanation there that actually indicates that that's not scary, there's no actual security related information shared, there's some metadata shared about the secure element. But it would mean that if you can actually do this metadata exchange based on the secure element, they implement it in such a way that the data that is shared, you should not be able to connect a user to be a single security token across different services.
Right, but could you, as a website owner, block out people who don't use a certain lockdown operating system, for example?
Yeah, you could. Yeah, of course you can. Well, operating systems, that depends a bit, but you can lock out specific tokens. So you can require that it has to be like a Google Titan key or of a specific version, or you can require that it has to be an Apple passkey. You can choose that.
Yeah, my question is, for instance, I share a family account for Netflix with my family, and now I just share my password. But how would this work with this kind of authentication? Should I go with my phone, or if I don't have a phone, how would I?
It depends a bit on what the implementer or so the relying party does. If you have seen the video presented by Apple, they really showcase an additional feature on top of their passkey implementation that allows you to show a QR code on one screen. Then you bring up your mobile device, you scan the QR code, something happens between these two devices, and then at that point the device is logged in. Mm-hmm. So in that case you would, I reckon, be able to share a Netflix account with multiple parties. Another route would be that you actually take your passkey and share it to another device, but then there is of course the requirement that it has to be an Apple device. So you could, for instance, imagine that your mother-in-law has an iPhone and an Apple TV. Then you can share the passkey with her phone, and then she takes it home. Because of iCloud keychain syncing, it's also available on her Apple TV, so you can just use it to log in. At least that's how I would expect these things to work once they ironed out all the kinks there. And I reckon that's going to be difficult, of course, but.
Yeah. Okay, thank you.
Okay. If there's no other questions.
One more.
Yeah.
So you mentioned it works nicely with OAuth and OIDC.
Yeah.
But does this spell the end of signing with Apple?
Hard to say. It is signing with Apple is like a social login, and I do think that Apple will be moving signing with Apple to more this type of authentication. But I do think that Apple is hedging their bets there, that they want to see if there's industry adoption of this PassKeys and WebAuthN first, before they actually start forcing relying parties to have to implement WebAuthN if they want to be able to do sign-in with Apple. It would make things a lot simpler, I think, because you don't have to do any of this crazy API calls with Apple services themselves. So who knows? I hope so, because it would take out Apple as a middleman when doing your login. So, any other questions? And that's probably the last one. So, is it soft enough?
Thank you. And sorry. Yeah. First of all, thank you for a very great, awesome presentation. And my question would be like, what is going to happen with two-factor authentication in this situation? Because I didn't see, I couldn't notice nothing that is happening actually. I missed the password, and I know that this covers already, but like, that is just an extra strap above and top in the security.
That's also one of the arguments with WebAuthN and key-based, security key-based authentication, is you don't need the second factor authentication anymore because of the level of security that you get because of the private key on the key and only the public key being shared with the relying party. The thing there is that because the thing that you log in with, that's the signature on something that the server sent, it's tied to a single relying party, and if you are able to be a man in the middle on that event, you cannot reuse that on any other service that you have registered yourself with your security token, and that's what two-factor authentication is aimed for to prevent, that you actually can show a time-based 6-digit code usually that proves that you are in fact in possession of a specific device that generates these numbers. And it is addressed in the WebAuthN specification why they think that 2FA is not required anymore if you do WebAuthN. And what you quite often also see with a lot of services adopting WebAuthN in some level is that they actually use it as some sort of second factor authentication. So they do a username password, and then to up your security they want you to do a U2F presentation, and that's basically a one-time password type thing, but then cryptography based. Wow, nice word. But that's also done with one of these secure keys. So you can go in between. You can do a username password login and then do a WebAuthN if you'd like, but that's kind of like defeating the purpose. And you see a lot of these samples that you enter a username and then authenticate. That's even not required. It's just a convenience for the implementer that they don't need to do a lookup based on the signature that they get back with the metadata to have to look up who it actually is calling at the door. So you can do different levels of implementation there. I hope I answered your question actually.
Thank you. So I don't have any other.
Yeah, so if there's no further questions, if you just want to catch the cube, just raise your hand then, because then he can try and hit you with it. And otherwise, I'd say let's grab a drink and have a break so that Donnie can set up and get us ready for the next talk.